Okay, we are going to be working on proving similarity. We're going to start with example 2 on your note sheet. And we've got 3 triangles here. We have our original triangle, which is our DEF triangle. We have our D prime, E prime, F prime triangle, and then we have our double prime triangle. And our original triangle was dilated by a scale factor of 3 to get our prime. And then it was translated and moved around. And what we ideally want to get to is the point where we can describe a sequence where we're going to prove that triangle D double prime, E double prime, F double prime is similar to DEF. And this symbol right here, which looks kind of like the congruent symbol without the 2 lines underneath, means similar to. All right, so like we did in Module 2, where we were explaining a sequence of transformations that maps one shape onto the other, we are going to be doing that here, but we're going to include a dilation. So this is where the similarity comes in rather than the congruence. All right, so we're going to start by deciding, okay, so the original was dilated by a scale factor of 3. What needs to happen to take the new shape and dilate it back to the original? And what we need to do is dilate this by the reciprocal of the scale factor. So we're going to take this, okay, and we are going to start with the dilation, or we're going to dilate triangle, the double prime triangle, from center O, which is here, by a scale factor of 1/3. So we need to identify all of these points. Okay, to start off with. So D double prime is at -12, 3, or -3, pardon me. E double prime is at -9, -6, and F double prime is at the origin. And if you recall, to find the new dilated points, we take these points and we multiply them by this new scale factor. So if we're multiplying by 1/3, it's the same as dividing by 3. So we're going to take each of these and divide them by 3. So -12 divided by 3 is -4, and -3 divided by 3 is 1. Or -1, excuse me. So we're going to be at -4, 1. Here, when we divide both of these by 3, we're going to get -9 divided by -3. I'm sorry, -9 divided by 3 is -3, and -6 divided by 3 is -2. So we'll be at -3, 2. And because 0 divided by any number is going to remain 0, F double prime remains at the origin. So there's our first order of business. The next step we need to take is figure out what we need to do to start moving this back onto the original. And so we're going to do a translation. So we're going to translate. And because we made a new figure, we're going to call all of these points triple prime. So that'll be the triple prime triangle. Okay, and prior to now, we've been creating a vector between points, but because we're on a coordinate plane, we can just count spaces. So to match corresponding points one to the other, I want to get F triple prime onto F. I can just move it to the right 2 spaces. So that would get it over here. And really our shape now, because we're moving everything over twice, we kind of have, if we were to use patty paper, we would end up with a shape that's right here. Our next order of business would be to rotate it so that these sides line up. If I rotate it, it's not going to map onto itself. But so we want to get to a point where we're going to create a line of reflection. So we're going to rotate, and we're going to go clockwise. And we're going to use this point right here. We could call it F, or we could also name it by its coordinates. I will name it by its coordinates of 2, 0. And then we end up with our shape that looks like this. So now it's matched up on a line, and we can use this, now this matched up line as our line of reflection. So our last part of the sequence is going to be to reflect over line DF. And because we have proven that this can be mapped onto the original, we can say that therefore, these 3 dots mean therefore, triangle, double prime, the double prime triangle is similar to the original.